Hi, this is our boat trip project by me, Eric.
And me, Hector.
So our goal here is to improve fuel efficiency and performance in marine vessels through advanced lighter materials. I am an electrical engineer, he is an industrial engineer, and we wanted to find a way to combine both of our engineering field together. So how can we do that? Well, we can do that with rate reduction, basically reducing the weight of the boat. For example, right now boats are made of steel. We can change the material and put it like carbon fiber or other stronger materials. Efficient manufacturing, as I said before, we somehow create a better material to produce more boats because steel is very limited and steel is very hard to get with like other metals. So innovative propulsion, like I said before, the lighter the boat, we create a lighter boat. The lighter the boat is, the farther the boat would go, the faster the boat would go with the current propulsion that the boat has on the system. Structural integrity, we love structural integrity. He's an industrial engineer. We got to make sure the boat doesn't break midway to the ocean. We got to bring our boys back home, like in Fortnite. We gotta take our boys back from the storm. So structural integrity, keep the boat secure and don't break. Environmental and economic impact, we don't want to harm the turtles because we love turtles here. That's why we're in Galveston. Our economic impact, we want to make money. We're both broke college students and we both want to make money somehow. So we want to make sure it doesn't blow up too big, but it doesn't blow up too small where we end up bankrupt. So the role of chemistry is we want to create advanced material like carbon fiber. Carbon fiber is basically just carbon but condensed. Corrosion resistance, we don't like corrosion. We did a whole corrosion lab about this, and we just want to find a way that our material doesn't corrode like with other steel and other materials. Cleaner fuel equals using less fuel. The less fuel we use, the better fuel efficiency the boat has. Battery technology, I'm an electrical engineer, so I want to integrate that into somehow creating a better boat, and we just did a whole electricity unit. Environmental protection, we love the turtles. We don't want to kill the turtles, so how do we not kill the turtles? We try to make sure our material doesn't harm the turtles if it falls off or etc.
So our duties was Eric was a research facilitator and team manager, and I was a team facilitator and product manager. So our first example is the SS Salima. It was built out of concrete due to a steel shortage, but the accident occurred and nothing could be done due of the ship being made out of concrete. In order to avoid mistakes like this, industrial engineers can streamline processes and use better materials, test out better materials like aluminum to make sure that the ship, this doesn't happen again, that the ship just sinks in the water and nothing can be done. And electrical engineers can install systems that can check corrosion in the hull of the ship to make sure that everything's A-okay. In the battleship Texas was a very famous World War era ship, but however it requires frequent repairs. So electrical engineers, they can invent systems to be constantly checking the corrosion of the ship to make sure the hull integrity is all okay. And industrial engineers can test materials and facilitate the transport of materials when it inevitably needs to be repaired. In the towboats are used to transport materials by either pushing or pulling. The larger section of the boat is used to carry corrosive liquids, but it can cause pollution. So, industrial engineers, they can test products out and make sure that each liquid is as least pollutive as possible. And electrical engineers, they can install electrical systems to ensure that the boat keeps together and not spills or the hull integrity is okay to just reduce chances of spilling. In the shipyard, it illustrates the shortcomings of materials in the industry. A shipyard is basically if a boat needs a repair, it will drive up to the shipyard and get a repair. However, it can be a very slow process. So industrial engineers, they can work on ways to sort of speed up the process, and electrical engineers can build electronic technologies to be scanning the boat and to pinpoint exactly what's the issue and how to solve it. In the vertical lift railroads, Galveston Causeway Vertical Lift Railroad is a vital link between boats and trains. Materials used to construct this must withstand corrosion and mechanical strength. Improvements can be made that increases structural integrity and energy efficiency. Both electrical and industrial engineers can contribute on the improvements made on the bridge.
So scientific evidence. So I did the research. He also did the research. So how do we improve fuel efficiency and performance? The simplest one is reducing the weight on the boat. The lighter the boat, the less fuel the boat is required to use for propulsion. And we want to get from point A to point B the fastest time possible. More oil you have on the boat means more weight the boat has. And right now, the weight needs to be reduced so we can have more oil and use more of that oil to propel us faster. A second way is to use advanced materials like carbon fiber and alloys to improve the vessel design, like the one shown in the picture. The top of the boat is made of carbon fiber and the bottom of the boat would be made from metal, and that would save us a lot of metal material required to create the top of the boat, as the top of the boat is just mostly for cosmetics and there's no really any point of it except for protecting the humans driving the boat, because we don't want to die in the middle of the ocean. So literature findings and real applications. So right now there are current trends in marine engineering where they're trying to create lighter weight materials such as carbon fiber. In Forbes magazine, they actually discovered that in Europe, people have been inventing boats with carbon fiber to create a faster boat, and then they would call this racing yachts, and they would start gambling a lot of money on these racing yachts because they want to create a faster and faster one, or basically something that you would see out of a spy movie that Tom Cruise would be driving. So Magna Marine also found the trend in the lightweight designs. So the lighter the weight of the materials, the more faster and more fuel efficient the boat is.
So our scientific approaches in engineering, electrical engineers, they can invent energy efficient propulsion, intelligent energy management, and renewable integration. Industrial engineers, they see the bigger picture. They can focus on automation, material selection, and cleaner fuel options to make better boats and more environmental friendly boats. So here in our boat, humanity started off using wood and then heavier wood to withstand warfare. And then around World War I, we started using metal, stuff like steel. And then ever since then, we've been using lighter and lighter metal, stuff like alloys, to reduce emissions and overall make our boats more sustainable and renewable.
So what is the future and where do we see ourselves with the vessels? So right now we want to create lighter weight materials to improve boat efficiency. As you can see with the photo behind you, the boat is covered in solar panels, and you might ask, why is that? It's because the boat's main power source is the sun. There is very minimal oil on that boat. The only boat that would use oil like that would be in emergency situations, which is why we wanted to create a hybrid system of electric engineering and then oil, so that way we can have the best fuel efficiency possible. And you can see on some parts of the boat right there, it's actually made of nanotechnology and graphene composites. For example, solar panels are made with nanotechnology, and then the graphene composites are mostly what made up the roof of the boat. Thank you.
Thank you.